In this video we look at the mean and standard deviation for a discrete random variable. So we're looking at chapter 5. So if you recall, we looked at random variables. They can take on different values and we have an associated probability p of x. So here are the definitions for mean and standard deviation. The mean, you take each value of the random variable times its associated probability and add them up. So it's kind of like a weighted average. Each value x times its associated probability. The standard deviation then is squared deviations away from the mean times its associated probability. Now we do have a shortcut formula where you can take the expected value of x squared minus the mean squared and then the square root of that result. Now don't forget that the first thing you need is you need the probability distribution function. You need to know the probabilities associated with each value of the random variable x. So if we look at an example, this one we're looking at x equals the number of pizzas per week a person orders. Okay? So in this case we let x equal 0, 1, 2, and then we group 3 or more. So here somebody did a survey and we collected some data, and 8% of people order no pizzas a week, 51% of people order 1 pizza a week, 39% order 2 pizzas a week, etc. So here we're given the probability distribution function. So if I wanted the mean, or the average number of pizzas per week that a person orders, I would simply take each value of the random variable times its associated probability. So 0 pizzas times 8%, 1 pizza times 51%, etc. If I add all those up, I get 1.35. So a person on average orders 1.35 pizzas per week. Now, obviously they don't order 1.35 pizzas, but on the average, in the long run, and that's the idea of the mean or expected values, what we would expect to happen in the long run. Now, if we look at standard deviation, it's a similar idea. It's just a little more of a tedious calculation because we need this expected value of x squared, which is the same thing, only I'm going to take x squared times the probabilities and add them up. So in this case, I take 0 squared times 0.08, 1 squared times 51, 2 squared times 39, 3 squared times 0.02. So there's your expected value of x squared. Add all those up, and then I subtract the mean squared, which I calculated earlier. So subtract that 1.35 squared. Plug all that in, take the square root at the end, and you have the standard deviation is 0.6538. A second example, here we have to construct the probability function first. So we have a box of marbles, and we're going to draw 2 marbles out. 6 are red, 4 are blue, and 15 are green. And here we're going to count the number of green marbles. So G is our discrete random variable here. So the first thing we note is there's 3 possibilities for G. I draw 2 marbles. I could have neither one of them green, I could have one of the 2 green, or both of them green. So I need the associated probabilities. So if I think about the probability rules for a sequence of events, I can figure out these 3 probabilities. If I want no green marbles, that means both of them have to be red or blue. So the probability of the first one is red or blue would be 10 out of the total of 25. Times the probability the next one is red or blue would be 9 out of 24 because I've already pulled out one of those. Similarly, G equals 1, I could think I draw a green one and then something else, or I could draw something else and then a green one. And G equals 2 is the probability both of them are green. So 15 of 25 would be the probability the first one I draw is green. Assuming the first one is green, now there's only 14 green ones left out of 42, or out of 24. So here I get my probabilities, and notice if I add these probabilities up, they total 1. In probability distribution, the probabilities should total to 1. Now, once I have these, I can now plug into my mean and standard deviation formulas. The expected value of, that should be a G there, expected number of green marbles would be 0 times 15%, 1 times 50%, 2 times 35%. So on the average, I will draw 1.2 green marbles. Now again, in any one experiment, I would not draw 1.2 green marbles. But if I did this experiment over and over and over again, on the average, I draw about 1.2 green marbles. Similar variance, again, that shouldn't be an x, that should be a g here. Our random variable is g. But the variance, I'll take g squared times the associated probability. So 0 squared times 15%, 1 squared times 50%, 2 squared times 35%. Add those up and subtract the mean squared. That's that shortcut formula for variance. Now notice here I do not take the square root at the end because it was asking for variance. So the variance would be 0.46. If I wanted the standard deviation, I would simply take the square root of that result.